Right, so we're going to do day 2 of our unit circle. We're really close to finishing. Okay, we have traveled around the circle using degrees and radians. Okay, and today we're going to actually name each with a point. So it's day 2 unit circle. And I guess what I want to show you really quickly is let me just talk to you about this for a second. And you don't need to write anything, just listen to me. All right? We talked about, for example, if I want to discuss this point right here on the unit circle. I can get to that point and we call it 30 degrees. Agree? Everybody's good with that? We also call it, we want to use it in, we want to use radians. We would say how far is it from the start here? And this is usually circumference. What measure would that be? Pi over what? 6. In other words, the distance from here, the distance from the beginning all the way to that point is pi over 6 radians. The distance around the whole thing is 2 pi. Okay? Now, so that's another thing we talked about, pi over 6. We have one more issue. They named that spot a third way, and a third way is using points. Because really what this is, and it's kind of hard to see on here because it's not written, but this is actually, if you took a unit, the coordinate grid, okay, this circle fits right here. Do you see what I'm talking about? So therefore, it fits on a coordinate grid. So this point is approximately on a coordinate grid. It's, even if the circle was gone, it would be right here. Well, it's hard to label that. It's not quite 1 over, not quite 1 high, correct? So I'm going to show you how to find it. Okay, and this is what happens. I'll use a highlighter to kind of help you see it. Okay, in order to get to that blue point, we're going to go this far out and this high up. Do you see it? That's, well, no, we're not going to use Pythagorean theorem. We're actually going to do something else. But you're on the right idea. Okay, this point here, the 45, look, I'll use an orange for that, goes out here and here. Notice the orange marks are exactly the same. And what they're the same, aren't they? Because what kind of angle is that orange mark? It's a 45, right? Which means the legs of a 45 are the same. Isn't that a 45-degree angle? Okay.
Why did that one angle up a little more?
I was just trying to not mark on itself. Being really technical. I was trying to get an idea. Yeah.
Does that mean the 45-degree angle?
No, it just means that these two are the same. Okay. Now, then the last one, which we're going to touch, let me see if I can get there. What degree is this? 60. Okay, and then this triangle, look, I've got to travel. It's hard to figure out on there very well, but this distance over and this distance up. So these are 3 different spots on my unit circle. So what I'm going to teach you is what they're called. They're not 1, 1, are they? They're almost 1 and almost 1, right? Okay, so I'm going to show you how to get it, these points. And the awesome thing about it is they're all the same. Okay, they just look different because this is a 30-degree angle going this way. Well, what's this going this way? Right. This is a 45 going this way. We'll flip it over. This is also a 45. Do you see it? So it's the same exact 3 points the entire time. So if I can show you one time, will work the whole way. Okay? So let's start then. I want to start with a 30, 60, 90 triangle. This isn't that one. We have 30, 60, 90, don't we? The 30-degree angle, a 45, or a 60. Or if there's a 3 we dealt with. Well, the 30, 60, 90 is going to deal with 2 triangles of the 3 that we just had problem with. Right? Y'all, I don't know if you remember the rule because we don't use it very often, but in a 30-degree 90, there's this really cool trick. And they tell you this side is x, this side is the square root of 3 times x, and this is 2x. And the awesome thing, what makes this, they call it a special right triangle. What makes this a special right triangle is that you can know one side and then get every single side correct. You only need one side in 30, 60, 90. Okay? So let me refresh your memory on actually doing that. So here's the original setup of the triangle. There's a 90 degree. This is not drawn to scale, so just bear with me. Pretend those are 30 and 60. And look what I wrote. I told you that the 30, can you guys do me a favor and trade this? Make this 30 up here. Okay, thank you, I'm sorry. Now, follow the directions. What side goes with 30? Look at our little cheat sheet here. X, so across from 30 is x. What side goes with 60? This root 3x. So across from 60 is root 3x. And what goes with 90? Excellent. So this triangle I just built you is the same thing as what's in the cloud. I was just visually showing you. Right? Now I'm going to give you a problem. I'm going to show you how to do one. Here's our right triangle. We're going to pretend this is 60 and 30. Like I said, it's not drawn to scale. And I'm going to give you one tip. I'm going to tell you that's 12. And then your job is to use the picture or use the cloud to find the rest of the sides. So that's 12. What does our little thing tell us? 12 is what? Same as 2x. So if this is 12, what is this? All right, you can mathematically show yourself. All right, I know 2x and 12 are the same. So x must be 6. So this is 6. Which makes it very simple. What's this? If x is 6, how do I fill in this side? Square root of 3 times 6. But we don't write it like that, do we? What goes in front? The number or the radical? Right, so how do we write it? 6 root 3. Do what?
I remember that.
Remember that part. Okay, one part at a time. Okay, now here's another issue. Let's see if I can get another unit circle for you. Okay, in a unit circle, one very important issue. I'll just use the same one. Okay, in a unit circle, we can actually draw lots of right triangles in here. But my question to you is, just like in this problem, I told you that the radius, I'm sorry, not the radius, the right triangle, the hypotenuse is 8, or it's 12. I used 12. Okay? In here, we're dealing with 30, 60, 90. So I want this triangle. This is the triangle I want. Okay, this is a right angle. Agree? So here is our 30-degree angle. Here's our 60-degree angle. What is the measure of this piece right here? We don't know this one, but we know this. I know it represents 2x, but in the unit circle, what is it? I heard it. 1, because it's called a unit circle, because what's the radius of everything in the unit circle? A 1. And doesn't this pink line right here represent a radius? So this is 1. So now, do me a favor. Draw yourself a triangle. So this is 1. Draw yourself a triangle and find me the pieces. If you have a triangle, you know it's a right triangle and it's a 30, 60, 90, so I'm just pulling it right off the page. Okay, now hang on, be careful. We're going to flip this. I'm going to put the 30 there. Are you watching? Be careful. Why did I do that? Because look, make it match this. 30's here. Okay. Now, across from the right angle, what did we decide? What was the hypotenuse of this triangle? 1. What's across from 30?
1.
In the formula,
One
half.
half.
Right, 2x equals 1. So what's x equal?
45.
Right, so across from the 30 is 1/2. How do we decide across from the 60? How do we decide? What's across from 60?
1/2 is square root of 3.
1/2 times the square root of 3. If I take 1/2 times the square root of 3 and put it over 1, you end up with the square root of 3 over what? Square root of 3 over 2. Okay, this very next step is really important.
We want to do just put 45.
No, they're going to want 1/2.
They want the right.
That's just how it was accepted. I didn't know. Okay, now the next part is probably the most important cloud you're about to make. Do me a favor and let's think about putting these in order. Of these three numbers, which number is the smallest? And we don't even need a calculator to decide which angle is the smallest. 30, so which side has to be the smallest? Okay, so 1/2 is the smallest because it's across from 30 and that's the smallest angle. What's the next smallest number? Root 3 over, right, because 60 is the next smallest angle, so across from 60 is root 3 over 2. And then that, which is about like 0.6, just a little bit more than half. And the next is 1. That is in order. Okay, so across from the 30, hang on, what did we do? Across from the 30 was the, come on, focus with me. Across from the 30 was 1/2. You're going to need these numbers. We're going to use the same numbers in the whole unit circle. So across from the 30 was the 1/2. Across from the 60 up here, across from the 60 was what? Root 3 over 2, and then 90 was the 1, right? Okay, so go back to dealing with the other angle that you're going to run into a lot. 45, 45, 90. Right? Don't we have a lot of those? Okay, and on the 45, 45, 90 triangle, we use x and x. Of course they're the same. The angle is the same, so the side across from it is the same. And then the square root of 2x. Okay? Draw yourself a triangle. It's a 90-degree triangle. It's a 45, 45. We know the hypotenuse of the triangle is 1 because that's the radius of the circle. And then the formula calls for the other two sides to be x and x. Now I'm going to give you one to try. Oh, I'm sorry, this should be square root of 2x. Now here's a triangle, give it a shot. What if I tell you that this is 8? If I told you that that's 8, you find the rest for me. I'm going to clean this up a little, I'm sorry. See if you can find the two sides. Use your triangle, use your picture. This one's a little harder. I know that the square root of 2x should equal 8. What do I have to do to both sides? Divide by, I want x by itself, so we divide by the square root of 2. I don't know what you remember from algebra, but are you allowed to leave a radical in the denominator? You will get so good at this by the time Capella is over. Can you leave a radical in the denominator? No. It's called rationalize it. And let me show you how. I'll show you right now, but we're going to study it a lot more later. In order to rationalize it, you multiply the top and the bottom by the square root of 2. So let's test. 8 times the square root of 2 is just 8 root 2. Outside stays outside, inside stays inside, is what I tell the kids. Now look at the bottom. What's the square root of 2 times the square root of 2? It's the square root of 4. What is the square root of 4? 2. It just drops the radical. Can anything reduce? The 8 and the 2. you get 4 root 2. So if this is 4 root 2, the other side is also 4 root 2. Okay, now that I showed you how to do that, you do it for the unit circle. Because our radius on our circle, is our radius 8? No, what's our radius? What's our hypotenuse? 1. So do it with 1 so that you can get the points you need. I'm going to tell you that's 1. Now you try it. See if you can find the legs. What'd you get? You want to guess? I know it's hard because you have. What do you? What?
1/2 over, sorry, 1/2.
You're right. It's 1/2 times root 2. It's root 2 over 2. That's right. So let me show you the math behind it. We knew that the square root of 2 times x should equal 1. So we divide both sides by the square root of 2. But we cannot leave a radical in the denominator, which means you're going to multiply the top and the bottom by root 2. So therefore, x equals 1 times root 2 is root 2, and root 2 times root 2 is the square root of 4, which is 2. So each side here is this. Guys, you have now named absolutely every single point you need in the entire unit circle. There's only 4 numbers. Okay? They are 1/2, root 3, and root 2 over 2. And then you do 0, 1, 1, 0. Okay, now, the little bitty circles you got when you came in, do you get those out for me? The little bitty ones, right? We're going to use all 6. Turn them sideways, not up and down. Well, I guess you could do them. They'll fit in your journals better. Whichever way you like it. I think last period I did that. Alright, here we go. I just wanted to show you so you can see this better in your head. One of the things you need to solidify to be sure you understand, okay, watch, this one's important to make a connection. When we had a 30, 60, 90 triangle, okay, 30 was 1/2, correct? This is important. Because that's the small one. 60s are bigger and it matched root 3 over 2. Right? And on 45, we use root 2 over 2 for both. Because it's a 45, 45. They're going to be the same. Alright, ready? That's important. So remembering that little piece of information, I'm going to do 3 colors. You can do what you want. So I'm going to start here, and I'm going to go here to here. Now don't go all the way. Because I'm trying to get to this point, correct? And in order to get that point, do I go all the way out? If I go all the way to here, I've gone too far. Do you see it? Okay, all I want is this. Now, this is a right triangle. I know this is 1, because that's the radius of the circle. What I wanted to show you is, because that's my first stop, what angle is this? A 30-degree angle. What distance is across from a 30? 1/2. What distance then, if that's 30 and that's 90, what happened? What's this one at the top up here? Of what? That's a 60, but yes. So diagonal from the square root of 2 is root 3 over 2. So if you wanted to name this ordered pair, in other words, if I'm trying to get to this point, how far to the right did I have to travel? Root 3 over 2. And how far up did I have to travel? 1/2. Okay, Okay, I'm hoping this will work. I'd like to show you this as well. I call it long and short. Okay, we already decided that the shortest distance was 1/2, and the longer distance, the long distance went with root 3 over 2. Do y'all agree? Okay, watch this and it'll make your life so much better. Okay, when I'm going from here and then up, this distance here is the long distance. So I'm going long, short. Long answer, short answer. Do you see it? And it works the entire circle. I'll show you, so give me a minute. Okay, I'm going to erase this and then go to the next one. Okay, go to the second one. Circle. This time the dot that we're going to go to is, how do you put it? It's the middle. Okay, and remember, to get there, you're going to go out almost here and then here. Agreed? That's how I get there and connect. We know that's a 1. We know it's a right triangle and it's a 45. What did we learn about 45s when you have a hypotenuse of 1? What's the measure? They're both the same, aren't they? This is root 3 over 2, and this is, root 2 over 2, and root 2 over 2. It's a 45, 45. Of course, you're going to go the same, out and up. So therefore, the point is root 2 over 2, root 2 over 2. Okay, last stop. You stopped at the 30, you stopped at the 45. What's the next stop, guys? The 60. So let's stop at 60. Okay, now, just when you watch, look up here for a second and look what happens. You remember when we went to this first stop, I told you it's long and short? Watch. Short, long. You see the lines? This is the short line, this is the long line. What did we decide the short line was? I'm glad you all paid attention because that was a hard question. What's the short line? 1/2. Because this is a 60-degree angle, guys. Isn't it? To get, if you put a dash line there, look. From here to here is 60 degrees. Right? Okay, but I don't have that much room, so I'm writing really tiny. So I just said that this was 60. Which makes the other one a 30. Every triangle basically is a 45 or a 30-60. Okay, so if that's long, then across from the 60s, you're root 3 over 2. So what do you think my ordered pair is going to be? 1/2 over and up. Isn't that how you find an ordered pair? So 1/2 root 3 over 2. Okay, the next part I'm going to show you really quickly. I'm going to use the same colors, and I want to show you the pattern going the other way. Okay, watch. Ready? Okay, I want to go to this point here. And it's, guess what, guys? It doesn't matter what point you want to go to. Watch how easy it is. Okay, I'm going to go left and up. What is that going to be? Long and what? Long and short. Don't we do x and y first? So long would be root 3 over 2. Short's 1/2. But which one's negative? Oh, left and up. Which one's negative? Yeah, the first one. Isn't that cool? No, it's just reversed. Go to the middle one now. You gotta use blue. The middle dot on the other side, that's this dot. You see it? Okay? So you're gonna go over and up. They're the same, aren't they? Because that's a 45. That's a 45, they're the same. So what point do you think that one is? Negative root 2 over 2, root 2 over 2. Negative root 2 over 2, and then root 2 over 2.
So one of the,
I'll get there. Just give me, you're on the right track. Just let me have some time. The other one we went to is here. Remember, we're always starting in the center, so let's get there. We're going to go short and what? Short and long. Short means negative 1/2. Long is root 3 over 2. Pretty easy, isn't it? Okay, what I want you to do now, that unit circle that you worked so hard on earlier, and you class? Get it back out. Okay, I'm going to use a blank one. Just because I want to walk you through it. Easier. But okay, let's start with this first point. We decided long, short. What does that give us? Root 3 over 2, 1/2. Now go to this point, the second one. It's the same in the middle. The middles are always what? They're 45, so the root 2 over 2, root 2 over 2. Pay attention, the test is soon. Now go to this point. Let's start in the center. I would go short, long to get there. Do you see it? I'm going to go short, long. So that's going to be what? 1/2 root 3 over 2. Okay, what about this one? That's on the axis, isn't it? What are you going to call it? 0, 1. I'm not going any left and right. I'm going to go all the way up to the 1. I forgot the first one. What are we going to call it? Careful. 1. No, not over 1. Over 1, up and down, 9, 1, 0. Okay, you ready? Let's see if you can get this one right. I'm going to go here. From the center. Okay, physically watch me. This is going to be short, way up high, long. Do y'all see it? Short, long. So negative 1/2. Okay, when you have quadrant 2 written down here already, can you do me a favor? Beside it, negative, positive. And that what happens here? All the x's are negative. Go to the next one. What's the middle one always? That's an easy one. Root 2 over 2. But the first one's negative. The x's are negative. These are ordered pairs. This first value is x. Okay, this one. Long, short. So we're going to call it negative root 3 over 2, 1/2. And you guys might see patterns. Watch this pattern. These are the same, aren't they? These are the same. And these are the same. See the pattern? Right. Okay, what about this one here? Negative 1, what? 0. You label this quadrant 3, and we were going to call it negative, negative. Everything down here is negative. Quadrant 3. Okay, I'm going to say long and short. So negative root 3 over 2, negative 1/2. Okay, I'm going to give you 2 minutes to try to fill in the rest. See how you can do. Okay, let's check these because I don't want them to be wrong. So finish up. The middle is negative root 2 over 2, negative root 2 over 2. What's this one going to be? It's going to be, right, negative 1/2, negative root 3 over 2. Down here, 0, negative. Okay, try again. We're going to do short, long. This is quadrant 4 with positive, negative. What's this point, guys? 1/2, negative root 3 over 2. Positive root 2 over 2, negative root 2 over 2. And then root 3 over 2, negative 1/2. Okay, you filled it in. You know every single point now on the circle.